Hello everyone, and welcome to another one of my real boring videos in the electronic shop on this drizzly day here on Memorial Day. This here is a Cornell Dubilier capacitor substitution box that I bought from Steve. Polish Hot Dog is his channel. And he emailed me last week and asked me if I wanted this. And so I bought it from him, and I got it in the mail the other day. It is sort of a match to this one, which I bought on eBay a few years back. This is the resistor substitution box. Basically the same thing, same period of time. Probably in the late 50s, maybe early 60s. It has two switches on it. Two binding posts where you put your leads to go to your radio, TV, or whatever you're working on to have the substitution of the capacitor you need in the circuit. I want to show you the back of this. Apparently at the factory this was calibrated. So let me turn this thing over and show you what I was describing on the back on my flap video I did a few days ago. As you can see here, and I don't know how well you can see it, there's handwritten, and this is apparently from the factory, of the capacitors in the unit, in the different ranges, different capacitors, and you can see there are handwritten fractions of the capacity. Now this thing was made, I understand, in the late 50s, maybe as late as 1960. I'm not quite sure exactly when it was made. I'm sure somebody would be able to chime in on that for that information, but to my knowledge, back in the late 50s or early 60s even, don't think they had any such thing as digital readouts. So everything was done with analog meters. So how they get these fractions, I don't know, unless maybe at the factory they have this type of equipment. Maybe it's Nixie tubes. I don't know, because they didn't have LEDs back. Well, they did have LEDs back in the early 60s, because I used to buy LEDs from Polypacks in the early 1960s. But whether they had digital readouts, I don't know. So I'm kind of at a loss there. But what I want to do with this is I'll put this through its paces on my capacitor checker. So let's do that now. I have two capacitor checkers. I have a Chinese one. Well, actually I have three. I have a handheld Chinese one that I got on eBay a few years back. I also have the B&K right here, and that's the one we're going to use. This one I got off of eBay also a year or so ago, and the battery compartment contacts were bad in it, so I have to run it on a 6-volt battery, which I have here. So we're going to start out using this one to verify the capacitor tolerances on this unit here. So I'll be right back. Alright, I don't know how Steve checked this out, but I tried all the ranges on the low ranges here, okay, and I'm getting crazy readings on this thing here. I I have checked this meter out on capacitors before, and you know, I could take a .047 and put it across here, a .01, and it reads pretty close to that. Now, I'm set for .01 right here. I don't know if you can see that right there. From what I understand, this should work the same as, I don't know if I'm in camera or not. I can't see the viewfinder. You set one of these on 0, and the other one you do your ranges. All right. So this one's on 0. This is the height, the small capacity ranges, and this is the little larger one. Well, the largest capacitor range on this is .01. So it's really quite small in values. I didn't realize that, because I don't use these small values too much. Most of the stuff I use in substitution would be 001 and stuff like that, 004. Here's your 001 over here. Well, I'm set on .01, and I'm going to have to get my head in the way. I'm sorry, I can't do it any other way. I'm on 1,000 nanofarads here, okay? I tried, this is a 0 adjustment here on this B&K. If you short the leads out, it just gives you a line across here, it does nothing. You take the leads out, and you can't really zero this, but it's worked in spite of that, but it don't seem to be working on this. I'm set on .01 here. Now, I'm on, I'm reading upside down. I apologize. I cannot do videos like most of you guys can do. I have to do everything upside down, sideways. I got the camera mounted on a stick over my bench, face down. But everything is turned upside down for me, so I'm having a very hard time with this. It's not as easy to do these things like I thought I could do. All right, so let's move up back to 1,000 nanofarads. Let's go to 10 nanofarads. This is a pain in the ass. Honest to God, I hate nanofarads. Let's move to 10 nanofarads here. I'm reading upside down, so I won't see what I'm doing until I play this video back. Okay? So, what am I looking at here? 0.007. Okay? 007. That is 0.01 or 0.01 right here. I gotta stand up. The camera's up over my head here. 0.01's right here. But I'm reading 007 here. So, I think we may have to get one of them Chinese meters and get that out and see if that'll do better. Because this here, before we do that, let's get a 0.01 out of the drawer here. Let's put it across here on the leads. I've got my leads right here on little wire stems coming out here about 1 inch long. And I got my little clips. I made this clip thing up. It did not come with these leads. I had to make them. And so you want to keep your lead short on capacity, but being that this is a 0.01, this don't really matter. It's a substitution box at very high capacity. Really won't work too good. Alright, I'll be right back. Let me get a 0.01. I'm not going to change the range on this at all. Let me get a 0.01 and remove these leads and put it on a 0.01. I'll be right back. Okay, I'm back on a 0.01 capacitor right here. I think it's mostly in camera. Right here, I disconnected these, and I'm still reading 0.007. So I know this meter was accurate when I got it from eBay. Let me go down. Excuse my head, I got to get it right in here. Now I'm reading 0.4. I don't know if you can see that, but I'm reading 0.4. I'm in the 100 nanofarad range, and I'm reading 0.5, 0.4. It's jumping all over the place. Let me just move this up until I can get 0.01. Here it is. Here's 0.01 right here. I'm on 100 nanofarads. I'm on 100 nanofarads here. I hate this nanofarad stuff. It drives me up the wall. I'm sorry, I hate it. We didn't have this stuff in years ago. We had microfarads, picofarads. All right, so that is reading 0.01 right there. All right, now let's take it off of this. Let's put it back on here. I'm working sideways, upside down here, so you'll have to excuse me. Okay, we're on 0.01, and we're on 100 nanofarads. Don't know if you can see that. 100 nanofarads right there. Okay, so I guess 100 nanofarads is 0.01. I got a chart that I downloaded year or so, 2 years ago, that converts nanofarads to picofarads and all that stuff. I just have to hunt it down. It's buried in my shop here somewhere amongst other paperwork. Okay, so that's 0.01. Now let's go down to 0.009. All right, we're not getting anything on 0.009. Let's drop, I would say drop it down and see what that reads. 0.006. 0.006. Now that's upside down. But that's a 0.009. Okay? And we are on 10 nanofarads. Okay? 10 nanofarads. So let's drop it down to 1,000 nanofarads. And no. Okay, so we need to be here. No, we don't. 0.006. Let's see if you're in camera here. There's a lot of reflection on here. I can see that in the shop. But as you can plainly see here, that's point. I'm looking, don't forget this viewfinder, I'm looking on this, I'm using the JVC camera. The viewfinder is upside down. I can flip the screen around where it'll go right side up, but then I gotta look up under the camera. I got to get my head right in the way of the lens, so I can't do that. So I'm looking at the viewfinder, and the viewfinder's upside down. But so everything's at a disadvantage in this shop. All right, we wasted a lot of time on this. Let's get the Chinese meter out, and maybe we can do a little better with that. Hang on a minute. We're on 0.01 now. And oh man, I went to damn nanofarads again. I did have 0.01 showing on this, but when I turn the camera on now, it's giving picofarads, and I'm sorry I can't read that without getting my ugly head right in the way of the camera. Alright, so I'm going to let you be the judge of this thing. I'm going to tell you where I got this dial set. Well, I think you can see it, but there is a reflection. Okay, so let's go, let's start from this end, all right? So what we're going to do is we're going to put this dial all the way to 0 here, and we're going to go to 0.0001, 0001, which is right here. So we're going to put it on that now. So we're using the high range here, okay? We got this switched to 0, okay? So let's put this on. I'm going to let you judge this, okay? I'm going to just show you what readings that's going to be showing on here. Here we go. 0.0001 microfarads. All right, can you see that? Let me look up at the screen, see if this shows in there. Yes, I can see it plainly on there, but with my bad eyesight, I can't see if that says nanofarads or microfarads. Okay? I apologize if on the other meter, if I was reading things wrong. I'm going by my piss poor eyesight. Okay, we're going to go to 0002, 0.0002. Okay, next test. Pay attention now. 0.0002. 0002. Okay, we go to 0003. 0003. Right here, 0.0003. Okay, next one is going to be 0004. This is going to be 0004 coming up, 0.0004. I always say 000 or 00, even though they're not O's, they're zeros. It's easier to say it that way. The next one is going to be 005. 005 coming up to a computer near you. 0.0005. Okay. Next one is going to be 006. This is going to be 006 coming up. 0.0006. Okay. Next one is 007. 007 coming up next. Next one is 008. 008 coming up next. 0.0008. Okay. 009. 0.0009 coming up now. And the final one on this here is going to be 0.001, 001 coming up here. 0.001. Okay, now we put this to 0 and we start stepping up. Coming up next to a computer near you is 001. 0.001. Coming up here. Okay, now the next one is going to be 002. 0.002. Coming up here. I'm not even looking at this because I have to get my ugly head in the way, and I don't think you want to see too much of that. Coming up next is 003. .003 coming up here. All right. Coming up next is 004, .004. Coming up after that is 005, .005. Next, 006, .006 coming up next. I have another meter that I ordered from eBay too. It's a regular capacitor checker also. But I figured to get this out because this video is going to be too long, and you know how it is with editing on a HD. .007 coming up next. 007, .007. Okay, the next one is 008, .008, 008. 009, .009 coming up here. And finally, the last one, .01 or .01 coming up on the screen now. Okay, so there it is. I'll let you be the judge. It's only as accurate as this meter, but as I showed on the back of this thing, we'll disconnect this. We'll take the battery off. You can see how I made this with the battery clip on it. And I guess I'm in camera, I don't know. No, I'm not. I just got the battery like that so I can save the battery life by disconnecting it when I don't need it. So, as I showed on the back of this, the calibration that apparently was done at the factory. So that concludes the video on the Cornell Dubilier capacitor substitution box. What really throws me off is these nanofarad things, and it's a real pain in the ass, to be blunt with you, to have to keep referring to a conversion chart, which I didn't bother getting out, so that I can figure out what these nanofarads mean. I don't care how many times you tell me, I cannot remember. So it would be much better if these testers, including that B&K, would show things in microfarads and picofarads rather than nanofarads. All right, that's it. This video is much longer than I wanted it to be, but thank you, Steve. By now you should have, or by this coming week, today's Monday, Memorial Day, by this week you should be getting your payment in the mail. I sent it out within an hour after I received the package. So, that is it. I want to thank you again for watching. Take care, everybody.